Okay, looks like we're recording. I will share my screen. All right. So I've never cleaned this particular data set before, and so I'm going to mess it up probably, but I've got Tidyverse, Janitor, and Palmer Penguins loaded. And you're used to Palmer Penguins because of the Penguins data set, which is beautifully tidy, ready to plot, all nice. But it also comes with Penguins Raw, which is presumably not that tidy. So let's see here. Okay, we got a space in a file or in a column name, capitalization, another space, capitalization. So right off the bat, I'm going to clean up those column names. But I also see that we've got 8 more variables as columns. So like Coleman length, mm. Yeah, okay, so a bunch of stuff in there. Okay, I'm going to save this as dat, clean names, right? So taking penguins raw, cleaning the names first off. Now I can look at it. Oh dear, okay. We got a study name. That wasn't in the final data set. Sample number, species, region, island, stage, individual ID, clutch completion, date. What's in the tidy data set? Names of penguins, species, island, bill length, depth, flipper length, body mass, sex year. Okay. Flipper length. Is Coleman bill? Let me just Google here. The upper ridge of a bird's bill. Okay, awesome. So that's bill. Okay, so I'll start there just because I just learned a new word. Coleman should be bill. We're trying to get penguins raw into the penguins format here. So names of dat. Names of dat. Replacing Coleman with bill. Yep, I'm happy with that. The names of dat shall now be the names of dat where Coleman has been replaced with bill. Beautiful. All right, that's done. Now I look at dat again. Species. Oh man, there's just a whole lot here. I'm coming up. I'm giving in. Library skimmer. Skim dat. Okay. Clutch completion, sex, comments, that can go. Date egg, it's listed as a variable type date. I haven't really worked with those, but that's a special type. Numeric, sample number, bill length, bill depth, flipper length, body mass. Those are the ones we want. Okay. So I might as well just type them out. Dat select bill length mm, bill depth mm, body mass G, flipper length mm. All right, what else did we have in the penguins, the tidy version? Species, island, sex, and year. Okay. Species, island, sex, and where are we getting year from? From date egg. At least that's the only place I can think to get it. So I'll just go ahead and replace dat with this trimmed down version. Dat. It's just those. Okay. We're going to need to clean up the values here. We're going to need to extract the year from these dates. The island looks good. And then the species, in the cleaned version, it's just like Adelie, Gentoo, Chinstrap. So we'll just take the first word there. Okay. I'm happy with that. So first up, let's get the date. Dat, date egg. We want to turn that into year. The class of this is date. So since we're working with a date, not a standard character string, I'm going to load up lubridate. You've already got it installed if you have tidyverse. It's just a separate call to the library to get it loaded. And it's got a whole bunch of built-in nice things where you give it a date and you can say, show me the year, show me the month, show me the day, time, hour, minute, second, all that good stuff. Okay, so that's nice. So here in our chain of commands, I'm going to say mutate year equals date egg, the year function to extract that year as numeric. And then I'm going to select to remove date egg. We don't need it anymore. All right. Nice. We got year. Okay. In the tidy version, I believe male and female was all lowercase. Penguins, dollar, sex. Yes. Oh, and I see levels. So levels mean that we're dealing with a factor. Okay. Mutate. Sex shall be. We're going to take sex. We're going to say string to lower. Make it all lowercase. And then say factor, where the levels are male, female. Were they in that order? Female, male. Date egg doesn't exist. Oh, right, because I've been writing over dat this whole time. Okay. That looks better. Island looks good. And then let's pull the first word off of this. Don't need any of that other junk. So what can we do? My first instinct is to split this on the spaces and just take the first thing. So if I say dat species, there we got them. If I'm working with strings, it's a good idea to try str underscore, and then it gives, we got a nice list of things that we can do with strings. We can extract stuff, we can flatten, glue, replace, remove, split. Okay. String split, string pattern. It's got the string because we piped it in. The pattern is a space. So we've split this up. It's now a list object. This is a new one. And so what this is we've got 334 observations. Each one contains 1, 2, 3, 4 elements in a single character vector. Now we just need to extract the first one. Now I would urge you to look up this map series of commands. It comes in tidyverse also, and it's for working with lists. And it's something called functional programming, where we can apply a function to every item in a list simultaneously, or, well, one at a time. So map lets us map some function onto every item in a list. In our items, there's the first item. It's in double brackets. So let me just step back and show you what a list kind of looks like. I'll call this L. So there's our list of 344. The first item in the list uses double brackets. Inside of that is a character vector for long. Okay. If I show you L down here, you'll see number 343 is chinstrap penguin, Pygoscelis antarctica. So L double square brackets 343. That kind of goes into that item and just gives us the thing in there. So we want to do that to all 344 of these. Okay, I'll delete that now to get it out of our way. So we want to map some function, and map character lets us return a character vector without having to do anything else. It's a little shortcut. And if the list items are named, we can give it a name here, or we could just give it a function like max or min or whatever. But really, we just want the first item. And so I'm going to say map character 1. Give me the first thing. There they are. Okay. Well, that goes into our mutate. So there's that. Okay. And then I'm going to say species is now equal to species piped to string split on a space, which is then piped to map character, where we extract the first thing. All right, I'm going to highlight everything down to that point, rerun it all. There we go. Now dat, species looking good, island, sex, year. Okay, not too bad. This wasn't terrible. The names, let me pull this out as well, get rid of it. Names of penguins are in that order. Ours are not in that order. Let's go ahead and put them in that order. Okay, so nice way of doing that, since we've already got these here, the names of penguins, that gives me a little shortcut. I won't have to reorder these. I could say dat select and then species, then island, then bill length mm, and it puts them in that order, whichever order you decide in select. But I'm lazy. This might give me a little warning. No, it did okay. Because the names of penguins, the cleaned up version, it just put them in that order since we made a match. And so that'll be my final, I think final little thing. Highlight that all, copy it down, and now we've got dat, and we've got penguins, and let's see if they're identical. Everything will have to be exactly the same. False. So we're missing something. Okay. 39.1, that's a factor. Ooh, species is a factor. Island is a factor. And penguins. In dat, character. Those will be a problem. Okay. So let's use the map again, just to show you another way of looking at this. One thing to note is that a data frame is really just a list. Each column is an item in the list. They're in that specific order, left to right, if you will. And it's a special kind of list in that each item in the list must have the same number of elements. So since it's actually a list, I can say map class. I'm going to ask what class every column is in dat. Ooh, see? It returns it as a list, so I'm going to go back and say map it as a character class. There we go. So species is character. Here in penguins, map character class. I'm going to apply class to every item in that list, which are the columns. Okay, so penguins, year is an integer, not numeric. Flipper length is an integer, so is body mass g. So I got to change flipper length, body mass g, and year to numeric. So dat, mutate. Flipper length is flipper length as integer, and body mass g equals body mass g as an integer, and year equals year as integer. Okay. So now let's see. Integer, factor, integer, numeric. Island, I've got it as a character. It needs to be a factor. And then species, I've got it as a character. It needs to be a factor also. So species and island, dat species as, well, we can just say factor levels equals, what levels are they in? So I'll turn to penguins again. Species, Adelie, chinstrap, Gen 2. Just going to copy those. And I'm going to say what possible categories and what order. Paste those in. They do need to be in quotes. Don't add a 0 there. Comma. So I'm making a little vector. Okay. That works. And then island, Visco, Dream, Torgerson. island. We'll turn it into a factor where the possible levels are those three islands in that order. So that's the order they'll show up in an x-axis on a plot or in a legend. If you're doing statistics, this is the order that things will be run through a model. And so your intercept would be Adeli and Bisco. You can change that up. If you wanted your intercept to be Gen 2, you would put that as your first. Okay. So this little bit here is handy. I'll add this to my mutate. Species equals species as this new funky factor. Okay. And then island shall be known as island still, but as a factor. I'm going to highlight everything, control enter it all. Now let's ask. Oops. Delete all this, paste that in. They're still different. Damn it. Okay. Those seem identical. I can find out. Yes. Okay, so it's not our column names. Dat map class map as character. Okay. Is that identical to penguins map character class? True. Okay, so the names of both data frames are the same in the same order. Their classes are all the same. So now it's the contents that are different. So I'm going to go back to skimmer, skim dat, and skim penguins. It's kind of annoying to look at. I wonder if I can just view it. It's a data frame. So we'll call that A and B. I'm saving the skims of A and B. So there's A and B. Only thing I think is maybe things are being rounded to a different number. Doesn't freaking look like it. Does look the same to me. Let's see. How should I find? I wonder if I can just try a full join on dat and penguins, and then view. Maybe this will pop up some weird stuff. 344. They joined perfectly. What? I don't know what's different about them. Let's get penguins into here. 344 of 8, 344 of 8, and that. They look the same to me. NAs are all in the same spot. Let's go to the bottom. Can't tell the difference. I have no idea. And I'm tired of messing with it for this video. So they look the same. So let's see. We cleaned the names. We changed Coleman to Bill. We'll do the cleaning to match the clean penguins data frame. And this bit, this extra mutate here, I'm just going to stick in to my cleaning script, that pipeline. Control Shift Home takes me everything up. Okay. There you have it. About 20 lines of code, including the calls to the different packages, and we've got it cleaned. Yay.